Good afternoon, everyone. We are the Safety System Integration team, and we're excited to present the outcomes of our project today. First, just some quick introductions.
Hello, I'm Mason
I'm
Bernard.
Andrew. I'm Andrew Curry,
I'm Ernest Soswapo.
And I'm Aaron Reed.
and today we'll be quickly revisiting our problem statement for anyone who was unable to attend the first industry presentation. Following that, we'll take a look at the system design, including mostly the programming of the main controller and safety controller within Sysmax Studio, as well as the HMI program that was written in GP Pro EX. After that, we'll look at cost estimates for like production costs, more so than development costs. Following that, conclusions, and then we will move on to client recommendations. And at the end, we'll have a question period. So please hold any questions you may have until then. Take it away, Ernest.
Firstly, I would like to introduce the problem statement. The client has requested the installation of a safety integration system in the mechatronics lab at SAIT. The safety system should be suitable for the demonstrations of concepts that were taught in class. We are required to utilize components supplied by Armor Manufacturing Company. The main goal is to wire and install the hardware devices, write the codes into the system, test it, documenting all information relevant for the successful completion of the project. Next slide, please. Here we have an image of the safety system network configuration. The safety network within the robotics lab consists of a standard Ethernet IP network and an EtherCAT communication bus. The EtherCAT stands for the Ethernet for Control Automation Technology. The EtherCAT applies Internet for automation application, requiring short data update time. If you look to your top left, you can see the EtherCAT master, which handles traffic to and from the safety system components located on the right-hand side, as well as communicating with the general network to facilitate the HMI integration. Only approved data types and variables are permitted to transition between the networks, and this is made possible by programs that run simultaneously on the main controller, the safety controller, and the HMI panels. Next slide, please.
Okay, speaking of HMI panels, featured on the left, we have the student HMI screens, or a representation of them. As can be seen, they start off just having the SAIT logo, as well as the robot name for each robot they're associated with. In the middle there, a reset light curtain button appears if it's required, and only if the instructor permits it. On the right, we have a short animation looping there with the top left of that animation. There's curtains and doors, doors removed and doors only for mode selection. To the right of those buttons, there's the doors removed student reset button, which is only available with the doors removed mode. And that is the button that allows the instructor to disable the reset light curtain buttons on the student HMIs. And the yellow buttons underneath are for the instructor to be able to reset individual robots when required. Very recent updates to this program have actually included graying out of buttons when they're unavailable. For example, in doors only mode, all of the buttons except for the mode selection buttons are grayed out because they're not required. That was a sort of last minute request from the client, and we were very happy to be able to provide that functionality. Next, we have the programming. On the right is the function block diagram language, which is used within Sysmax Studio and the safety controller. The safety controller only accepts function block diagram. It's a little bit hard to see, and we do apologize for that, but it was difficult to fit all of the information in one window. However, in the very top left, there's an activate input, and these inputs are what were used for the mode selection functionality. Below those activate inputs, there are just there's other inputs. These ones are for the light curtains and the door switches. And to try and keep it flowing, the logic kind of gets processed and hopefully makes it over to the, or it does make it, sorry, makes it over to the safety function external device monitoring block on the right. Now, if all that logic is true, or the the applicable logic to the selected mode, sorry, then a signal is sent to the relay within the robot controller saying, yes, it is okay for robot operation to proceed. However, if that logic becomes false, that signal to the relay also becomes false, and then that triggers the auto stop functionality within the robot controller. On the left, we just have a little representation of the ladder diagram that's actually in the main controller rather than the safety controller. The main controller accepts ladder language and structured text language. We didn't use structured text, but anyway, the ladder basically handles whether or not that student reset button becomes visible on the student HMIs. So if any of the logic on the very left there is false, then, again, depending on the mode selection, those buttons simply won't appear. Next, we have Aaron.
Hi, next up, we have a system demonstration. On the left, you'll see Andrew triggering the light curtains. In the bottom right corner, you'll see Sysmac. You'll see a little green line going up. That is logic to the relay. When it is green, that means that the logic is true. And when the light curtains are triggered, the logic to the relay is false. Next slide, please. Next up, cost estimate. We'll be going over parts, tooling, and labor. The main thing to take away from parts is we did substitute, or we basically for the main network controller and the safety controller, we upgraded the system so that way we could add additional output cards. And this is good for additional updates for the system in the future as well. Total for parts comes out about $47,000. Now for tooling, we use Sysmac Studio, obviously, GP Pro X for the HMIs. And this comes out to about $5,100. Next for labor, labor is based on production cost. Development cost would be roughly $100,000. And the total cost for the system, I can't see it right now. Something's in the way. I think $56,000 is the total cost. Next slide, please.
In conclusion, our team, after reintroducing the problem statement, we went over how all of the cell EtherCATs are connected back to the EtherCAT master and safety PLC. We then covered the HMI and how that works from the outside and the programming side. As you saw, the implementation was a success. We have the light curtains, the relays, the program, all working as intended. And lastly, we quickly went over how much it would cost to replicate the work that we have done in the lab. Next slide, please. Some recommendations for the client in the future are the installation of a bypass key switch in place of the HMI to better meet safety regulations. Another is to alter the light curtains to work with other capstone projects. For example, the Roptino project, where triggering a mute sensor at the appropriate time will allow the Roptinos to access through the light curtains without tripping the safety system. Another thing that can be installed is the LiDAR for extra safety, and this will prevent the light curtains from being reset while a person may still be in the robot cell. And the implementation of CIP safety will open up the opportunity more to a safe move of all of the robots. And lastly, a calculation of robot reaction times and safety times will allow for faster robot speeds to be performed in the robot cells. Next slide.
And that brings us to the trifold that we made for our project. And at this time, we're happy to answer any questions that you might have.
I do have one important to me. You may or may not know, we are actually changing one of the courses in this program. Okay. And there will be an expanded safety segment in the new course.
Awesome.
So I'd like to know from your team members what you felt was the most significant thing that we could teach over what you've already learned with respects to safety from a
With
student perspective?
With respect to safety, that's kind of a tough question.
It is. That's why I'm asking it.
Well, with respect to the safety software, I think one of the most difficult aspects was learning how to take the variables used in the function block section of the safety controller and actually communicate them with the general Ethernet IP network. As for specifically to safety, I'm not sure, Chris. I'm sorry. Does anyone else have a better answer?
Well, our safety systems can only be as safe as the people that are operating them.
That's a great point.
Protect against stupid. So you got to teach the people not to reach over the light curtains, not to sneak in with the Robotinos, not to try to reset the light curtains while your friend is still in the robot cell. Yeah.
So
thanks, Mason.
So getting around human behavior.
Yeah,
is that what I'm hearing?
I think that's a very strong point. Yeah, it's a huge challenge because especially unsupervised or whatever, even in the workforce, as people who you would imagine would be quite mature and adult, that type of stuff still happens because I have several years work experience and I've seen all sorts of silly things. So I think Mason's points there were very good.
Yes, and this is what I have found is so difficult with programming for safety, working with a safety organization. But interesting to hear your comment on basically passing that information from one system to the other. I'll take that to heart and make sure we do cover that in the new course in a little bit more depth. Thank you.
All right, thanks, Chris. Do we have any other questions today?
Very detailed presentation. I appreciate the demonstration.
All right. Cool. Well, I don't see anything. In that case, thank you very much, everyone, for attending our presentation. Special thanks to the representatives from Omron who helped with troubleshooting and learning how to use Sysmax Studio, as well as a very special thanks to our technical and communication advisors within MET. And yeah, thanks everyone. I hope you enjoyed our presentation and that you found it interesting.
Excellent. Thank you very much.
Thank you.